In this lecture, I want to talk about accessing files. So files on disk have a name, and the rules for naming the files are determined by your operating system. You may have to adjust the names depending on what OS your program is running. If your program is running on Windows versus Linux, the directory structure is different as well. So if you use / or backward slashes, you have to adjust this in your program. But for the most part, the names are relatively have the same naming rules and so forth. But there is the chance that you'd have to adjust it. A program references a file through a file pointer or a stream pointer, since it works on more than just a file. You can actually, we mentioned this earlier, but the standard I/O functions work on any device. So it's called a file pointer, but it really can be it really should be referred to as a stream pointer. You associate a file pointer with a file programmatically when your program is run. So what you end up doing is you'll create a pointer inside your program. It will be of type file, and that's going to represent the file when you read and write to it. So we use these file pointers as a more effective way to actually point to the files as opposed to the name, right? Because the name can be a little bit different. The pointer will represent what it's actually pointing to. And you can reuse the pointers to point to different files on different occasions, which again was represented by the file name. A file pointer points to a struct of type file that represents a stream. You can actually go and look at the file struct to see everything that's inside of it, but it contains information such as whether you want to read or write or update the file, the address of the buffer and memory where you're storing data, a pointer to the current position in the file for the next operation. We mentioned the position is important because that's where you're doing your writes and reads. And you can set all this information inside the structure by using input and output file operations. Right? The input and output file operations, when you open a file, it's going to actually specify whether you want to read or write. And then also when you can change the current position by using other methods like seek and so forth that we're going to talk about. If you want to use several files simultaneously in your program, you have to create a separate file pointer for each file. You can only reuse the file pointer if you're reading and writing at different times. There is a limit to the number of open files you can have at one open time. You can look at the limit in the standard I/O. There's a constant defined fopen max. It all depends on, again, what operating system you're running on. But you usually do not want to create and open a ton of files at once. Writing and reading the files is an expensive operation because you're writing on the hard drive. It's not as fast as writing to memory, so it takes time, and it can cause your program to be less responsive. So you don't want to have 10 files open and writing at 10 files at the same time. To open up a file, this would be the first step that you do before you read and write. So you want to associate a specific external file name with an internal file pointer through a process referred to as opening the file. The way that you open a file in C is you call fopen function. This will return the file pointer, which you can then use for reading and writing. And again, the file pointer is going to point to a specific external file that's on the disk. Fopen is going to take the name of the file. The fopen is what you'll usually do, what you have to do before you do any reading and writing. It's usually your first operation. And as with most of these functions, they're all defined in standard IO.h. Here is the definition of the fopen call. You'll see that the return value is a file pointer. It's all caps, the file structure. So all caps file. You'll then notice that it takes a couple of parameters. It takes a name and a mode. And don't worry about this restrict. That's just more C11 stuff. It really just takes a character pointer to a name and a mode. The first argument of the function is a pointer to a string that is the name of the file. So that will be inside double quotes. You can specify the name explicitly or use a character pointer that contains the address of the character string. So all this is saying is you could create a character string and assign it a literal text and then pass in the string to the function, or you can put in inside the double quotes right inside the function call. You can obtain the file name through the command line as input from the user as well, or define it as a constant in your program. It depends if it's always the same file you're reading and writing to and the name doesn't matter, you can just refer to it as a constant. If your program is more flexible, it can get input from the user to say what you want to read or write to. The second argument to the fopen function is a character string that represents the file mode. This specifies what you want to do with the file. Whether you want to read it, whether you want to write to it, whether you want to append to it. File mode specification is a character string between double quotes. And I'll show you some of the ones that we're going to end up using a lot of. Assuming the call to fopen is successful, it will return that file pointer, all caps. And then you can use this file pointer to call other input-output functions in standard I/O header. And we're going to go through those when we go through reading and writing. Or you can also get the position using that pointer to change the position of where you are in the file. If the file cannot be opened for some reason, fopen is going to return null. So what this means is, before you start doing any reading or writing, make sure that the pointer is not equal to null. Another if check. Here are the file modes that I mentioned. The file modes, remember, are the second parameter to the fopen call. This is what specifies what you want to do with the file. And it's all inside double quotes. So if you do a W, that means you want to open the text file for writing. If you do an A, that means you want to open the text file for appending. All writes are to the end of the file. If you do an R, it opens up the text file for reading. If you add a plus to any of these, it will basically create the file if it doesn't exist. So if you open up a W plus file, it will open it up for update, and it will truncate the file to 0 if it exists, or it will create a new file if it doesn't exist. With the other ones, it's going to write or read, and the file has to exist. Same with A+, it's going to open it up for appending, for an update to the end of the existing file, or create the file if it doesn't exist. And the R+ will open up the text file for update. It's not going to create the file there because it will be empty. So the reading is just for both reading and writing when you see the R+. A little different than the other pluses where they're actually creating the file if it doesn't exist. Write mode. If you want to write to an existing text file with the name myfile.txt, you would create your file pointer, all caps, set it to null, initialize it to null, and then you would maybe create your file as another character pointer, myfile.txt, or you could pass that in as the first parameter. And then you just say fopen. Fopen, file name, and then W inside double quotes. That opens the file for writing, and it returns a file pointer. That's why you have pfile on the left of the assignment. You then want to check to make sure pfile is not equal to null, because if it's null, if it failed to open for any reason, maybe the file name was wrong or it didn't exist, then you wouldn't be able to write to it. So you always want to do the if check and print out some information if it doesn't open. This code will open up the file, and it will associate the file with the name myfile.txt with your file pointer's pfile. The mode W means we can only write to the file. You cannot read from it. If a file with the name myfile.txt does not exist, the call to fopen will create a new file with this name. And that's for fopen with the W option. Right? And so when we saw in the previous modes, W plus will create the file if it doesn't exist, but it also truncates the file to 0. That's the difference with the W. The W will create it if it doesn't exist, but it's not going to truncate it to 0. Okay. So this is the standard way for opening up files using that W inside the double quotes. If you only provide the file name without any path specification, so that's what we did in this example. A path, remember, is the name of the directories. If you don't provide the name of the directories, it's going to assume that that file is in the current directory wherever the program is executing. If you want to actually open up a file somewhere else where it's not actually located in the program's directory, then you have to specify the entire path. That's called the absolute path. When you provide no path, it's usually the relative path. It's relative to where the program is running. So you can specify either one, the absolute or the relative path, just to make sure you know where it's located and you're doing the right one. Relative paths are usually better because then it's not dependent. If somebody were to move that file, it's not dependent on where it was moved. And you can actually do a relative path, and you can go back directories. So you can do a .. and that's relative to where the program is running. You're just going back a couple directories. When you use an absolute path, it would actually be something like C : program files if you're on Windows. And if that file ever moved, the program would not be able to open it. So on opening a file for writing, the file length is truncated to 0, and the position will be at the beginning of any existing data for the first operation. Any data that was previously written to the file will be lost and overwritten by any write operations. Okay? So again, without providing the plus on it, it just means you can't read and write. This is write only. W is write only. W plus means you can read and write. Append mode If you want to add to an existing text file rather than overwrite it, you can specify the A mode. This is appending. This positions the file at the end of any previously written data. If the file doesn't exist, it creates a new one. The example here is you just change the second parameter to be an A inside double quotes. It will add to the end of myfile.txt. And do not forget that you should always test the return value for null each time. You always want to do the if p file is not equal to null. When you open a file in append mode, all the write operations will be at the end of the data in the file in each write operation. All write operations append data to the file, and you cannot update the existing contents in this mode. It's all at the end. In read mode, we can open up the file to read a file. We just use the R inside double quotes. This is read only. You cannot write to the file. If you do R+, you would be able to read and write. So it looks like the other calls. You just do an fopen, pass in the name of the file, and then R in double quotes. That returns a file pointer. It will also position the file to the beginning of the data. If you're going to just read the file, it must already exist. You're not going to read an empty file. So there's no option of creating the file if it doesn't exist. It will just be empty, or you would get back the file pointer would be null. If you try to open a file for reading, it doesn't exist, it will return the null pointer. If it does exist and it's empty, you just return no data. You always want to check the value returned from fopen. Again, reiterating that for the second time, it's important because if it's a null pointer, your program is going to crash, it's going to do something bad. Renaming a file. We know now how to open a file. Opening a file is the first operation. You specify the mode and the name of the file. That gives you back the file pointer, which you can now use to do other things with. Renaming a file is sometimes important. It's very easy. You just use the rename function. It takes an old name and a new name as constant character pointers, and it returns an int. The integer that's returned will be 0 if the name change was successful and non-zero otherwise. The file must not be open when you call rename. Otherwise, it's going to fail because it's in use. You can't rename a file when it's in use. So what you can do here is you can just say rename, pass in the old file name and the new file name. In this example, we're using a path to a file in Windows. And that you know it's Windows because I C:. You also notice that the backslash is there twice. The reason for that is because the backslash is a special character in C, right? \n is a line feed. \r is a carriage return. So the backslash has special meaning in the program. So if you want to actually use the backslash for a path in a directory, which is what Windows does, you have to provide 2 of them. And so here we're renaming a myfile.txt located in the temp directory. We're renaming it to myfile_copy.txt in the temp directory. And if that is not equal to 1, it will fail. We just print out an output that says it failed. Otherwise, we print out successful. This is going to change the name of myfile.txt in the temp directory to myfilecopy. If the file path is incorrect or the file does not exist, it's not going to be able to rename. You can also close a file, and you'll want to do this whenever you open a file. So when you're done with the file itself, you want to tell the operating system to free up that file. Remember, there's a limit to how many files you can have open at any given time. You can do this by calling the fclose function. Fclose accepts a file pointer as an argument. Remember, the file pointer represents the file. It returns an EOF. EOF is an int. It returns EOF if an error occurs. EOF is a special character called the end of file character. It's defined in standard io.h as a negative integer. It's usually equivalent to -1. If fclose was successful, it will return 0. So you can check for EOF for unsuccessful. You just say fclose, pass in the pointer. You can then set the pointer to null. And the result of calling fclose is that the connection between the pointer, the p file, and the physical file is broken. P file can no longer be used to access the file for reading, writing, or appending, or renaming. If the file is being written to, the current contents of the output buffer are written to the file to ensure that the data is not lost. So you don't have any problems with data integrity. You're not going to actually close the file if it was being written to in another thread. So it's thread safe. We haven't talked about threads. That's more an advanced concept. But it's where you can have multiple execution points in your program. It's good programming practice to close a file as soon as you have finished with it. Just like it's good programming practice to free memory when you're done with it. Same for closing files. It protects against output data loss. You must also close a file before attempting to rename it or remove it. It has to be closed. It can't be opened. How about deleting a file? You can delete a file by invoking the remove function. This is also declared in standard io.h. All the file operations are declared in standard io.h. You can always go look at this header file if you want, wherever the C header files are installed. So you just say remove, name of the file. Here you don't have to use the file pointer. You can just say, because the file doesn't have to actually be open to remove it. The same with the rename, right? Because you don't actually want the files to be open, because the rename or the remove will fail. It's going to delete the file that has the name myfile.txt from the current directory. This is providing a relative path. It's going to look for that file wherever the program is executing. Otherwise, you need to provide an absolute path. The file cannot be open when you try to delete it, just like rename. You should always double check with operations that delete files. You could wreck your system if you do not. A delete is a very expensive, very hazardous operation. Deleting files can cause problems, so be careful. All the information in this lecture had to do with accessing files, how you can open up files, which is what you need to do before you read and write,